All right, let's dive right in. Today, we are looking at the next wave of AI, and it is coming at us from all sides. We're going to cover everything from some secret leaks to AIs that can read emotions, all the way to models that are literally trained under pressure. It just shows you how fast this field is moving.
You know, the future of AI isn't going to be some single giant breakthrough moment. It's happening right now, everywhere, all at once, and in ways you probably don't expect. So we're going to break down 4 of these brand new developments, and we're starting with a story that feels more like a mystery, a secret that was hidden in plain sight and probably never meant to be found.
So first up, the company DeepSeek. Now, this isn't some official press release. No, this is about sharp developers on GitHub piecing together clues that all seem to point to the company's next big flagship AI model. You know, when the evidence is right there in the code, it's usually way more revealing than any marketing announcement.
Okay, so check out how this all went down. On January 20th, DeepSeek pushes this huge update to GitHub. Immediately, these eagle-eyed developers spot a new, strange identifier scattered all over the code, Model 1. And literally by the next day, the whole community was buzzing, speculating that this had to be a new flagship model. Rumors were even flying about a release date right around the Lunar New Year.
So the big question was, is Model 1 just some minor update? Well, the code tells a very different story. The current model V3.2, that's a known thing. But this new Model 1 identifier, it popped up 28 times. And here's the kicker. The code explicitly treats it as something separate from the old version. That is not how you do a simple version bump. That's a massive clue that you're looking at a whole new architecture.
And when they dug deeper, developers found 3 huge technical clues. First, a totally new KV cache layout. Now, you can think of the KV cache as the model's short-term memory. If you're redesigning that, you're probably going for way better speed. Second, a different way of handling sparsity, which is basically a clever trick to make the model faster by only using the specific parts of its brain it needs for a task. And third, support for something called FPA decoding, which is all about squeezing every last drop of performance out of the newest hardware. So you put it all together, and these are not minor tweaks. This stuff screams new architecture. And this is where it gets really interesting. It lines up perfectly with DeepSeek's own recent research papers on new training methods and even biologically inspired AI memory. So the big theory now is that Model 1 is actually DeepSeek V4, and it could be the first model to bring all that cutting-edge research to life.
All right, let's switch gears for our second story. We're moving from detective work on code leaks to a very real model you can get your hands on right now. The company Zipu AI just dropped something called GLM 4.7-Flash, and this one is all about putting some serious AI power back into the hands of developers so they can run it on their own machine.
The very first thing you need to know about this model is this number, a massive 128,000 token context window. That means it can process and remember just a huge amount of information all at once. For complex tasks, that is an absolute game changer.
So you're probably wondering, how can a model with 31 billion parameters be lightweight enough to run locally? Well, the magic here is its architecture. It's called Mixture of Experts, or MOE. See, instead of firing up the entire giant model for every single calculation, it has a bunch of specialist networks inside. And for any given task, it intelligently activates only the experts it needs. It's incredibly fast and super efficient because of it. And it's not just efficient, it's a real powerhouse. According to Zipu AI's own benchmarks against similar models in its class, GLM 4.7 Flash is a leader in those core skills you really care about, like math, reasoning, and especially coding. Sure, other models are competitive, but this thing really stands out. It's not just accessible, it's genuinely powerful.
So why is this such a big deal? Well, for developers, this is huge. Most of the top-tier AI models are locked away behind super expensive APIs or require a whole server farm to run. This model is lightweight enough to actually run locally. It's got a free tier to get you started, and it plugs right into the tools that people are already using. It's making top-tier AI practical for way more people. Okay, for our third story, we are taking a hard left turn from practical coding models into research that honestly feels like it's straight out of science fiction. A team in Japan has actually built an AI that models how emotions are formed, not as some fuzzy feeling, but as a computational process that is tied directly to what's happening in our bodies.
The whole project is built on this really fascinating idea called the theory of constructed emotion. It basically argues that emotions aren't these pre-programmed things we have. Instead, your brain is actively building them in real time by mixing together internal signals, like your heart rate, with all the information coming from your senses.
From this point of view, an emotion is actually a kind of calculation.
So to test this wild idea, researchers fed an AI model 3 kinds of data, all of it completely unlabeled. They showed people images meant to evoke emotions, they recorded their physical responses with sensors, and they collected what people said about the experience. But here's the crucial part. They never told the AI what happy or sad was. It had to figure out all the patterns on its own. So, did it work? The results were pretty remarkable. The emotional categories the AI discovered all by itself actually lined up with what people said they were feeling about 75% of the time. That is way, way beyond random chance. It suggests the model actually learned to recognize real human emotional patterns just from looking at the raw data.
And the implications of this, wow, they're profound. Think about it. This could lead to emotionally aware AI assistants that actually respond to how you're feeling, not just what you type. It could be used for mental health tools that understand emotional states that people can't even find the words for, or to help monitor conditions like dementia. This isn't about an AI having feelings. It's about an AI understanding the complex patterns of human experience.
And that brings us to our final story. We're going from the subtleties of human emotion to the cold, hard logic of competitive programming. There's a new model out called NewCoder 14b. And it wasn't just trained to write code. It was trained to write code that could survive the most brutal tests you can possibly imagine. You see, most coding models learn by just reading billions of lines of code online. They learn to talk like a programmer. NewCoder's training was completely different. It learned by doing. It had to write code, run it in a sandbox, and see if it actually worked against tests it had never seen before. It's the difference between imitation and pure survival.
The training process itself was beautifully simple and incredibly harsh. The AI generates a solution to a problem. That solution gets run against a bunch of hidden tests. If it passes every single one of them within strict time and memory limits, it gets a reward, +1. But if it fails in any way, if it's too slow, uses too much memory, gets just one answer wrong, it gets a punishment, -1. No partial credit, absolutely no mercy. So, did this tough love training method actually work? Oh yeah, you better believe it worked. On a really tough benchmark, the base model it started from scored just under 61% on its first try. After this brutal training, NewCoder 14b jumped all the way up to nearly 68%. That 7-point leap is a massive improvement in a field where every single percentage point is incredibly hard to get. So there you have it. From secrets hidden deep inside code, to powerful models you can run yourself, to AIs that can compute emotion and others forged by pure failure. It's so clear that the ways AI is learning are getting more diverse and more powerful every single day. Which really just leaves us with one final question. When AI can learn like this, what on earth does it learn next?